Zoom will occasionally kick me off of the meeting just whenever my internet connection is slow or whatever. It's really pretty annoying. But I realized after watching the video that I cut out at around 23 minutes and 50 seconds or so, which was right as I was finishing up this problem here. So so I want to take over where we left off. We were pretty much done with this problem, but you should get about 29 for side B. So moving on to part D now. We've seen an ambiguous case where we had two solutions, where we had one solution, and I just want to show you one where we have no solution, okay? So if you draw out this scenario, you end up with a triangle that looks something like this. And if we go to solve this thing, again, we see that law of sines is going to be helpful for us, right? We can say, you know, for example, sine 50 degrees over 8 equals sine B over 15. And then we could solve for angle B, right? So we can say sine B equals 15 sine 50 over 8, which means that B is sine inverse of 15 sine 50 over 8. And what you get, if your calculator is anything like mine says error, domain error. Or yours might just say error or undefined or something like that. Well, let's see why. Let's forget about taking sine inverse for now. Let's just do 15 sine 50 over 8. So this would be sine inverse of 1.436 and some change, okay? Now, the problem with this is that, remember that sine is can only put outputs between -1 and +1. So taking sine inverse of 1.4, it's like you'd have to think of an angle such that sine of that angle is 1.4. That's not possible, right? So right off the bat, right out of the starting blocks, you can tell that that you've got a problem, right? Because this number here is more than 1. What that tells us is that there's no solution, right? No solution. This particular triangle is not solvable. We like the ones that have no solution because they end so quickly, right? Our work is done so soon. But yeah, that one has no solution. Okay, so we've seen several examples of using law of sines. Let's look at a couple where we would use law of cosines to solve the triangle. Okay, so let's draw this scenario. I'm claiming it's a side angle side. Let's see. So A, B, C, that means little a is 15, little b is 10, and C here is 60 degrees. So sure enough, we've got side, angle, side, right? So it's definitely a side, angle, side. And you'll notice that law of sines doesn't help us here, right? We could try to say something like sine B over 10 equals sine 60 over C, but then we're going to have two unknowns in that equation, right? And you can't use Pythagorean theorem to solve for the missing side because, well, this is not a right triangle. But what you can do is you can use law of cosines, which is an extension of the Pythagorean theorem. And you're going to use law of cosines to get this missing side, right? So, so what we would say actually is a squared equals, or no. We would say this: c squared equals a squared plus b squared minus 2ac cosine c. 2ab cosine c. Let me write it out. We would say c squared equals a squared plus b squared minus 2ab cosine c. That's what we would use. This one's for a squared and b squared, right? But this is what this would look like. So we would say, all right, because this is c right here, right? So we say c squared equals a squared plus b squared minus 2ab cosine c. And then you can simplify all of this mess and then take the square root to figure out what c is. So say c squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times cosine 60 degrees. That comes out to exactly 175. Isn't that lucky? It doesn't always come out so nice, but it came out to 175 in this case. So that means that c is square root 175. Which can simplify. I mean, I know 25 goes into that. Yeah, so this should be 5 root 7. Or if you want a decimal, you can say 5 root 7 is about 13.2. Okay, so there's c. Now what we need to do is find these other two angles. Now to find these other two angles, you could again use law of cosines, or you could use law of sines at this point. Since you have an angle and a side opposite of it, then you can use law of sines to get the others. And I think law of sines is a little bit easier to use personally. So that's what I'm going to do. I'm going to say sine 60 over 13.2, or actually maybe I'll use the exact value so it'll be more precise, but I'm going to say sine 60 over 5 root 7, we'll say. So sine c over c equals sine b over b, which is 10. So that means sine b is 10 sine 60 over 5 root 7, which means b is sine inverse of 10 sine 60 over 5 root 7. Let's see. Sine inverse of 10 sine 60 divided by 5 root 7 is about 40.9 degrees. Okay, so we've got C, we've got B. All we need is angle A now. So we can say, well, angle A is going to be 180 degrees minus 60 degrees minus 40.9 degrees. That's 79.1 degrees. So there you go. We know that C is about 13.2, angle B is about 40.9, and angle A is about 79.1. Okay, so that's how we would use law of cosines. Let me give you one last example of solving an oblique triangle. Again, we're going to use law of cosines here, I think. This time we're given side, 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 and it's pretty clear that that's what we're given, right? I'm still going to draw a little picture, though. 2, 9, 5.3. Side, side, side. Okay? So law of cosines. I'm going to say, well, it doesn't matter which angle I start off trying to find. Maybe I want to find angle A. If I want to find angle A, then I would use the version of the law of cosines that starts with a squared equals, right? So I'm going to say a squared equals b squared plus c squared minus 2bc cosine A. Then I can start plugging stuff in. So I can say a squared equals b squared plus c squared minus 2bc cosine A. And you see this is going to allow me to solve for angle A. So here we go. Oh, goodness. To simplify all this, well, 4 equals 81 plus 28.09 minus 95.4 cosine A. These things you can combine, you know, 81 plus 28.09 is 109.09, and then I'm going to subtract that from 4. So I'm going to say 4 minus 109.09 is negative 105.09 equals negative 95.4 cosine A. And we can solve for cosine A by dividing by negative 95.4. I'm getting something strange here. Hold on a second. 2 times 9 times 5.3 and 4 minus. Huh. Well, yeah, this triangle is not possible, right? Because we're going to get cosine A. Cosine A is equal to 105.09 divided by 95.4, which is more than 1. So you're getting cosine A is something more than 1. That's not possible. That tells us this triangle is not possible. Sorry, I wasn't expecting that, so I have to pause and think about it for a second, think about why this was happening. But it makes sense, right? It's like the sum of two sides of a triangle has to be more than the third side of the triangle. And here we're only going to get 7.3. 7.3 is not more than 9. So yeah, this triangle is not possible. This is not a possible triangle. So there you go. Maybe if we change this to like 7 or something. If we changed it to 7, here we would have 49 instead. And we can make this work. So 49 plus 28.09 would be 77.09. 4 minus 77.09 is negative 73.09. And then you divide that by the, and this would have to be 7 as well, right? So 2 times 7 times 5.3 is 74.2. Then you would divide the 73.9 by the 74.2, and you would get, yeah, something less than 1. So anyway, so the way the problem was originally stated, it wasn't solvable, but I'm going to change it so that it's 7, so that b is equal to 7. That will allow us to still at least solve this so that I can show you what to do from this point. But yeah, so we would get sine inverse of 73.09 divided by 74.2. Let's see about how much that is. So that comes out to about 9.9. Degrees, right? So that's a really small angle. This is about 9.9 degrees there. So then to get the other two angles in the triangle, what I would do next is you could use, again, law of cosines to find the other two angles, but you could also use law of sines, and in my opinion, it's a little easier, law of sines. So I would say sine 9.9 degrees over 2 equals, let's say, sine B over 7, right? And then you can solve for angle B. Once you've solved for angle B, then you can subtract 180 minus this minus that to get angle C, and then you're done. So maybe I won't take you through the rest of the nitty-gritty details of this problem, but that's that. Very interesting. The way it's originally stated, it leads to a triangle that's not solvable, that's not possible. But there you go. All right, so there's that one. That's all I have to say about solving oblique triangles. Okay. The main case to watch out for is side-side angle. That's the ambiguous case. Okay. So you have to check for a second possibility if you're solving a side-side angle. All right. We'll see you in 3.7.